Well, we saw in a previous video how to multiply radicals that have variables, or how to multiply with radicals. And now we're going to just put some variables in there as well. So this just adds a little layer of complexity here. So we can start off simple with the square root of 5 times the square root of 3x, like that. And as we learned before, we just multiply the things that are on the inside, the radicands. And this would be the square root of 15x. So just like we would multiply 5 times 3x, this is the same thing. We have the square root of 15x. Well, sometimes when we do that, then we can simplify it as well. So let's say we have the square root of 2y times the square root of 6y. When we multiply those radicands, we get 2 times 6 is 12, and y times y is y squared. So we look to see if we can simplify that. And you can probably already see how we can. We take the 12 and we separate it looking for a perfect square. We find 4 times 3. And then y squared is also a perfect square. It's an even number. So we are going to take the roots of the 4 and the y squared. Those will come outside the radical as 2 and y, right? The square roots of both of those. And then we leave the radical 3. 2y times radical 3. Next one. Let's look at if we add some complexity here. So let's say the square root of 5x squared y times the square root of 10x to the third y to the third. So this will require you to remember how to deal with some of those issues with square roots of radicals and variables, square roots of variables that have odd numbers. So do you remember how to deal with those? So let's start by just multiplying everything that's in here. We have 5 times 10, which is 50. We have x squared times x to the third. That's x to the fifth. Remember, we add those exponents. And then we have y, which is like y to the first, times y to the third, which is y to the fourth. So there's everything when we multiply it. Now we want to do what? We want to look at each of these different bases, so these different factors here, and break them into something that's a perfect square. 50, hopefully you'll notice, is 25 times 2. Now, do you remember what to do with x to the fifth? If it's an even numbered root, if it's 2, that's what I should really be saying. If it's a square root, we are going to break it into the highest possible even number, less than 5, which is 4, and then x to the 1. These two have to add up to be 5. We want the biggest possible even number. Times y is already an even numbered exponent, so we leave it as it is. So the perfect squares here are 25, and then any even numbered exponents on our variables, x to the fourth, y to the fourth. We are going to take the roots of those things. The root of 25 is 5. Now, do you remember what to do with these? We take half of it, x to the second, and this one too, y to the second. And then we're left with 2 and x on the inside. 5x squared y squared times the square root of 2x. All right, let's look at one more. So let's go with the square root of 10 u v to the sixth times the square root of 2 u v. So why don't you pause and try this one on your own? I will keep going. So the first thing we do is what? Simplify them into one radical. 10 times 2 is 20. U times u is u squared, and v to the sixth times v is v to the seventh. Then what? Then we separate each base, each factor, looking for a perfect square. For 20, we have 4 times 5. U squared is already an even numbered root, so we leave it as a 2. And v to the 7th, we're going to break up into v to the 6th times v to the 1st. They still add up to 7, and we've maximized our even number. I'm going to highlight the things that are perfect squares, the even numbered exponents, and that 4. And then we take the square root of 4, which is 2. We take the square root of u squared, which is u. The square root of v to the 6th, what's that going to be? V to the 3rd. We cut it in half. And then the leftover stuff on the inside is 5 times v. And so that's how we simplify, or that's how we multiply and simplify radicals that have variables in them.